Alright, Lesson 7C deals with finite geometric sequences and series. This is a little bit different than the lesson we just left, where instead of having a common difference between each term in the sequence or series, you're going to have a common ratio. So instead of subtracting the second term from the first term, we're going to divide. So geometric sequences are when there is a common ratio between each term. So if you look at these first four examples that I have here, what you want to do in order to determine that it's a geometric sequence and not an arithmetic or some other sequence is just simply divide. So if we look at 4 over 1, which is 4, that should give us the same thing as 16 over 4, which is 4, or 64 over 16, which is 4, or 256 over 64, which is 4. So these guys all have a common ratio of 4. Therefore, we would say, yep, it's a geometric sequence. Now, if you look at the next one, 2 over 1 is 2. 6 over 2 is 3. Already you see a discrepancy, so we know example 2 is not going to be a geometric. 4 over 1 is 4. 9 over 4 is not 4, so you can throw that out. All right, let's look at this last example. 100 over 1,000 is 1/10. 10 over 100 is 1/10. 1 over 10 is 1/10. So you do have this common ratio, and that ratio is 1/10. And so you could say example 1 and example 4 just both show geometric sequences. All right, so just like before, we had a formula to work with arithmetic sequences. You also have a formula to work with geometric sequences, and that formula says a sub n is equal to a sub 1 times r to the n minus 1 power. So a sub n is the value of the nth term, a sub 1 is the value of the first term, r is that common ratio we just talked about, and n is the term number. So if you look at the example and it asks you to find the 10th term in the sequence, -4 we could fill in for our a sub 1. 8 over -4, which is -2, is our ratio, so we can fill that in. I'm asking you to find the 10th term, so we're going to say our n is 10, and so a sub 10 is going to be -4 times -2 to the 10 minus 1 power. It's important that you follow your order of operations and that you use your parenthesis when you're using the calculator. You don't want to multiply before you deal with exponents. Exponents go first. So a -2 raised to the 9th power. Make sure you put that negative in the parentheses so it's going to be raised to the power as well, is -512 times -4 is going to give me 2048 is going to be the 10th term in the sequence. All right, so another way we could use the same formula is to ask yourself how many terms is it going to take for 2 to get all the way up to the number 3,188,646 if you multiply by 3 each time. So instead of sitting here working that out by hand, we're going to take our formula. Our a sub n is the value of the term that we're looking for, which is the 3,188,646. A sub 1 is the value of the first term, which is 2. R is what we're going to multiply each term by, which is 3. And we want to know how many is that going to take us to get there, which is going to be our n value. So we still have the formula n minus 1. So we're going to divide each side by 2. So the 3,188,646 When you divide that by 2, it's going to take you down to 1,594,323 is equal to 3 to the n minus 1, which is 3 to the n over 3 to the 1. You guys remember the quotient rule for exponents. Subtracting exponents get rewritten as a division. So now I'm going to multiply each side by 3. And that's going to take our number up to 4,782,969 is equal to 3 to the n. Now there are ways to solve this equation using logs, but that's not something that you're going to need to worry about till next year, or the year after. So instead of doing that, we're just going to work with trial and error. So let's take our calculator and figure out what power can you raise 3 to get you up to the 4 million. So you're thinking 4 million, that would be a pretty big one. So you might start at maybe 25. And that's entirely too big, so we'll back it down to 15. 15 seems just a little bit large. That's in the 14 millions. So we'll take it down to 11. That's a little bit too small. So it's got to be somewhere in between there. I'm just trying on my calculator. And it works out to be 14. We'll take you there. So your bases cancel out, and you know n equals 14. So just by multiplying by 3, it's only going to take 14 times to go from the small number of 2 all the way up to 3,188,646. All right, let's look at this example. We're going to continue to use our formula. If 1,024 is the 5th term in a sequence, so we have 1, 2, 16 is the 3rd term. Don't know what this one is. 1024. We want to know what is the first term in the sequence. So you kind of have to trick the formula a little bit because we don't know our ratio. So we're going to pretend like we don't even care about the front end of this, and we're just going to work with the 16 and the 1024. So just initially we're going to treat this as a sub 1 and a sub 3. And so if you know a sub 3 is equal to a sub 1 n minus 1, so we're going to say 1024 is equal to 16 times r to the 3 minus 1 power. So divide each side by 16. You're going to get the 64 there. And then you're going to get r squared. And take the square root of each side. And you're going to get plus or minus 8 equals r. So that means we're multiplying by 8 each time to get here. So if you back that up, what number would you multiply by 8 to get 16 is 2? What number would you multiply by 8 in order to get to 2? And that would be 1/4. Okay, you're not sure if it wasn't negative 2. So these guys, if it was negative 2, then these guys would just be negative. But either way, the 1/4 would be positive. Okay, so that doesn't change the outcome of the answer, even though your ratio could have been positive or negative. Sometimes it will, sometimes it won't. You just got to see where the cards lie. All right, let's look at this example using the sum formula. So now I don't want to know what a specific term number is. I want to know what's the total of all these terms. So my sum formula says the sum is equal to the value of the first term times the quantity 1 minus r to the nth over 1 minus r. So in this case, we know we want the first 6 terms in the series. So we have 1, 2, 3, and then I'm not sure that this is the 6th term. They haven't told me that. So instead of just assuming that, I should probably find the value of the 6th term. So I know a sub 6 is equal to a sub 1 times r to the n minus 1 power. So a sub 6 is going to be 10,000. Your ratio is 4,000 over 10,000, or 1,600 over 4,000. And so that's just going to be 0.4. And then 6 minus 1 is 5. So you know a sub 6 is 10,000 times the quantity 0.4 raised to the 5th power. And so that's going to be the 102.5. So it did work out that this is the 6th term, but you couldn't assume that. All right, so using your formula, you want the sum of the first 6 terms. A sub 1 is the 10,000. You get the 1 minus 0.4 to the 6th power over 1 minus 0.4. And we're going to use our calculator to help us do this. So 1 minus 0.4 to the 6th power divided by 1 minus 0.4, and then times the 10,000 is going to get us for a total sum of 16,598 and then 0.4. All right, let's look at the next example. It says in a single elimination soccer tournament there are 64 participating teams. So in round 1 we're going to play 32 games. Then in the next round we're going to play 16 games. Then we're going to play 8 games. And then we're going to play 4 games. 2 games for the final. And then that'll be the last game. And so you could just sit there, since this one's not too long, and add these up. And that's going to take you to a total of 63 games. Okay? But let's say you didn't want to just add them up. Maybe the numbers were too big or something. Then what we could do is find the sum. We know we started out with 32 games. Your ratio, if you can't tell here, is a half. 16 over 32, 8 over 16. So we have 1 minus a half. And then n is the number of times you're going to do this. So you'd have to count that out. So 1 round, 2 rounds, 3 rounds, 4 rounds, 5 rounds, 6 rounds. Using our calculator, we're going to work this out. And lo and behold, using the formula, you're going to get the same answer as you did when we worked it out by hand. Okay? So it's still, this just goes to show you that depending upon the problem, you might want to work it out long ways, or you might want to use your formula. All right, now let's look at this one. Find the sum of a series of 6 terms. I don't know the first term, negative 40. Don't know the third term, negative 10, 5, and 6. All right, so you're not sure what your ratio is because you don't have 2 terms back to back. So I can't figure out what all these numbers are just to add them up like that. So we're going to do the same kind of thing that we did earlier, is we're going to just kind of ignore that guy for a second and zero in on these 3 terms. This is also called a geometric mean. So we know a sub n equals a sub 1 r to the n minus 1 power. Okay, so we're going to treat negative 10 as a sub n. A sub 1 is negative 40. We're looking for r, and this is 3 minus 1 is 2. So you're going to get 1/4 is equal to r squared, which means your r value, again, you're falling into this category of plus or minus a half, equals r. So you're not sure if this is positive or negative, and that's going to affect the outcome. So you're actually going to have to run 2 on here. If this is positive a half, you're going to get, this is going to stay negative 20. This will be negative 5 and negative 2.5. And this is going to be negative 80. And you would add all those up. Or if this was negative 1/2, then you would work it out the other way. Your signs would change. So if you go to use your formula, S sub n equals a sub 1, 1 minus r to the n over 1 minus r. We're looking for the sum. A sub 1 is, we're just going to use the positive 1/2 right now. So a sub 1 is the negative 80. We get 1 minus, and then you're going to get a half, and n is 6 over the 1 minus 0.5. We're going to use this in the calculator, 0.5 to the 6, 1 minus that, and divide that by 0.5, and multiply that by 80. And so you'll get your sum is negative 157.5. And you could run this again with your r being the negative 1/2. All right, now sigma notation is a little bit harder to read. This is new for you. It's got this Greek letter sigma, and at the bottom you have the variable that you're going to work with, your starting number. Up here is your upper number, and then you're going to have your function or the rule that you've created. So if I add, and then it automatically means sum, so you know you're going to have to add this up. So if you expanded this, you're going to go from 8 3/2 to the 0 power, and you're going to keep with this until you reach 8 3/2. Okay, the 0 power came from plugging the bottom guy in here, and then we're going to stop when we plug this guy in here, which is 11. Okay, so we're going to add all of these up. And so if you just use your sum formula, S sub n equals a sub 1, 1 minus r to the nth over 1 minus r. All right, a sub 1 in this case is 8. 1 minus the 3/2. Now n is the number of terms in the sequence. If you start with 1 and end with 12, that's going to be 12 terms in the sequence. If you don't believe me, count it out on your hands. You always do the bottom minus the top plus 1. So I'm going to use my calculator for a second. And when you work this out, you're going to get that your sum should be 2059.941406. Okay, if you want to sit there and expand this all the way out and then add everything up, it's going to be a waste of time. We like to see you using your formulas. All right, so that's the end of lesson 7C. Let's see how you do with the classwork with it, and then we'll go on from there.